Hello everyone, my name is Raghav and today I'm going to present my research project Adversarial ToM, Reinforcement Learning for Natural Language Deception and Trust Modeling in Mixed Motive Settings. In today's age, recent developments in large language models have taken them to the heart of our most advanced systems, powering everything from seamless communication to complex decision making. However, one thing, when these agents enter environments where interests collide, where some participants may seek to mislead or undermine others, it becomes vital to prepare for exactly that kind of adversarial behavior. That's why there is a need to train deceptive LLMs and their trust modeling counterparts together. By intentionally teaching one agent to learn deceptive strategies, we create controlled attackers that probe every weak point. At the same time, there is also a need for another type of agent that learns to watch for these tactics, to infer hidden intentions, and to adjust its trust in others accordingly. In our work, we weave these two roles into a single adversarial training framework grounded in theory of mind. We fine tune both agents via reinforcement learning, a deceptive agent trained to mislead others to achieve its personal goals, and a trust modeling agent trained to detect deception and infer underlying intentions in mixed motive scenarios. Theory of mind plays an essential role in our work. Basically, a human's ability to reason about the thoughts, beliefs, and feelings of others to predict behavioral responses is theory of mind. A classic false belief example used in literature is the Sally Ann example. This test used to probe whether an individual can appreciate that another person may hold or act on a belief that differs from reality. Sally hides a marble in her box and leaves. While she's away, Anne moves the marble to her own box. When Sally returns, the question, "Where will Sally look?" reveals whether one understands that Sally holds a belief different from reality. The correct answer, which is in Sally's own box, shows the ability to track another perspective rather than one's own knowledge. An integral work in this domain is Google's ToMNet, a theory of mind neural network which uses meta learning to build models of the agents it encounters from observations of their behaviors alone. In our framework, we leverage a belief model to compute an agent's nth order ToM belief as a probability distribution over the identity of the agent. The mental net parses an agent's previous beliefs from a set of POMDPs to form a mental embedding. The observation net parses the agent's observations in the current episode to form an embedding of its perceptions, called the perceptual embedding. These embeddings are fed into the prediction net, which outputs the agent's nth order belief. In our adversarial training framework, the deceptive agent and the trust modeling agents are trained alternatively, keeping the parameters of the other type of agent frozen during each training step. One deceptive agent can be trained with a number of trust modeling agents. During training, the deceptive agent is rewarded for swaying the trust modeling agent's belief away from the ground truth, whereas the trust modeling agent is awarded for being as close to the ground truth as possible. Through iterative reinforcement during the adversarial training, both agents continuously refine their strategies, becoming increasingly adept at deception and its detection, respectively, learning more successful strategies to continue to be capable at the task against a stronger adversary. For testing our framework, we use an environment based on the social deduction game Among Us. Among Us is a multiplayer deduction game where players are either crewmates completing tasks or imposters sabotaging and eliminating others. Through discussion and voting, the players try to identify imposters before they eliminate all the crewmates. Such an environment provides a great opportunity to study decision making with partial information, deception, and deception detection. All the experiments we ran were on a 3 by 3 grid environment with one imposter and 4 crewmates. We find that the vanilla agent only had a 21% win rate against a vanilla imposter. However, after the first iteration of training, they rose to 43.3% win rate, showing a 2.1 times increase over their performance. Similarly, after training, the imposter's win rate against first iteration crewmate goes from 54.7% to 73%, showing an increase of 1.3 times. Some exciting directions to further expand this work would be to test higher order deceptive strategies like second order theory of mind deception or third order theory of mind deception, and training multiple deceptive agents together in a cooperative setting. This work was made possible thanks to the ONR MURI grant. Moreover, huge thanks to Professor Katia Sycara and Dr. Woojun Kim for being amazing mentors. Being a member of their lab and learning from their expertise helped me grow a lot during this summer and gave me experience I would never forget. Lastly, special thanks to Rachel Burchin and Dr. John Dolan for organizing the Robotics Institute Summer Scholar Program.